Okay, here we go again. We have a problem. We need to calculate the arc length of the graph of a function. What we know is that we want to calculate one part of the graph of this function, and we want to know what's the length of this part. Well, we're going to first indicate, to point out the whole part. And I mean, we take an interval from x equals to a to x equals to b. And this interval is the one we want to calculate the arc length of the function, of the graph of the function. So the first step is to indicate what's the whole. That's the whole, this part of the graph of the function. The next step is, well, I want to calculate its length, so I will give a mathematical name, this number, and I will use the symbol L in order to indicate this number, the numerical value of this quality that I want to calculate from the graph of the function. The next step is, well, I want to calculate the length. I am going to divide it in parts so that for each part I may calculate the length, and also that the whole is in its entirety divided. So the step 3 is to determine how I am going to divide the whole so that in each part we be able to calculate the quality that we want to calculate for the whole. So I am going to divide the interval from a to b in an infinite number of parts. All of them will be of the same size, and I will denote the size of each part by dx. So the next step is to point out a generic part that represents an infinitely small of all of those infinite parts in which I divided the interval from a to b, and this is this part. Now I want to calculate the length of this part, and I will give a mathematical symbol for the magnitude of this part, and I will call it dl. So the L represents the length of this tiny part of the graph of the function. The next step, well, I know the length, the whole length, the value L is equal to the sum of all the L's. I mean, this part that I have just shown here represents one of the infinitely parts that I have taken from a to b. If I add up all of the L's, I will get, as a result, L. So I will express L as the sum of all the values of the dL's. So L is the sum, this S represents sum, from a to b of all the dL's. This is the length, or this is the integral sign. The next step, well, I would like to calculate the L, and in order to do this, I will draw a right triangle, and since this is a right triangle, I will apply the Pythagorean theorem. Of course, since dx is infinitely small, dl is almost, if not, well, indeed it is, we will see it later, a straight line. So this segment dl is exactly the same as the length of the hypotenuse of the right triangle shown in this figure here. So from the Pythagorean theorem, dl will be the square root of dx squared plus dy squared. This part is dy. So f of x plus dx is equal to f of x plus f prime of x times dx, and this minus f of x was here. So after simplifying, f of x minus f of x will cancel each other, so I get f prime of x times dx and the square of it, and in this case dx came from x plus dx minus x and a square also. So this is the horizontal cathethus, and the other one is the vertical cathethus, and the root of the sum of the squares of the catheti will be the length of the hypotenuse. So after simplifying, I will get dl equals the square root of 1 plus the square of f prime and all multiplied by dx. So I already said L equals the sum of all the L's from A to B, and I already know what's the value of the L. This is the value of the L. So I will just substitute this expression instead of the L, and I will get the integral, which represents the exact value of L from A to B. That's it. Who has no questions?